Hey everyone! Today, we're going to do something a little different. We're going to dive into Amazon DynamoDB by following a student's actual project journey. We'll see how they started querying data, where they hit some, let's just say, very common walls, and how they discovered some powerful solutions that turned that frustration into a real breakthrough. Sound good? Let's get started. So, let me just ask you this. Have you ever been in the middle of building an application and just thought to yourself, you know what I need? A database that is just screaming fast, can scale to the moon without me even thinking about it, and is dead simple to manage? I'm guessing if you're a developer, the answer is a big yes. Well, the tool at the very heart of this project is Amazon DynamoDB. Before we jump into the student story, let's just quickly get on the same page about what this thing actually is. Okay, so at its core, DynamoDB is a NoSQL database. That just means it doesn't use the classic rows and columns you'd see in a relational database. It's built for speed and flexibility. But the real magic? It's serverless. That means AWS handles all the messy stuff, all the infrastructure for you. No patching servers, no provisioning, nothing. You just get to focus on your data. So why do developers absolutely love it? Well, it really comes down to these three things. First, it's designed for single-digit millisecond performance. That is crazy fast. Second, it scales up or down all by itself based on your traffic, so you're not wasting money or getting caught with your servers down. And finally, because it's fully managed, you get to be an application developer, not a database administrator. All right, that's enough theory. Let's get our hands dirty. Now, the student in this project started where most of us do, right inside the AWS Management Console. You know, the web interface. It's the perfect place to poke around and start exploring. Before we can run our first query, we have to talk about the most important concept in all of DynamoDB, the partition key. This is the main identifier for your data. The best way to think of it is like the main folder or the main category where your piece of data lives. When you want to find something, you have to tell DynamoDB which partition, which folder to look in. Okay, so what happens if you have a ton of items in that same folder? That's where the sort key comes into play. It's optional, but it's super useful. It acts like a subfilter, letting you zero in on what you need within that partition. And, like the name says, it lets you sort those results. This is how you ask for things like, give me all comments from this user, sorted from newest to oldest. And here we go. This is what it looks like in action. You can see the student is querying their comment table. They've given it an exact value for the partition key, which is ID, and then they use the sort key, comment date time, to find a very specific record. This combo, partition key plus sort key, is what makes lookups incredibly fast and efficient. And you see the result? It's exactly what they wanted. So far, so easy, right? So yeah, things are looking good. The console feels pretty intuitive, pretty powerful. But this is the point in our story where things take a little turn. What happens when the simple way just isn't enough? What if you need to filter on something that isn't a key? Let's say you want to find all the comments posted by a certain person, but the problem is that PostedBy field isn't your partition key or your sort key. Now what? And boom, you hit a wall. This screenshot shows exactly what happened. The student tried to query using an attribute that wasn't a key, and DynamoDB just said, nope. This is a core concept you have to get. Basic queries in DynamoDB must use the partition key. You can't just search on any old field. And here it is, straight from the student. This is such a classic aha moment, the frustrating kind, but an aha moment nonetheless. It really highlights the golden rule of DynamoDB. You have to design your tables based on how you plan to read the data. It's not like a SQL database where you can just write a query for any field on the fly. So are we stuck? Is that it? Not even close. This is where we graduate from the console and discover the true power that's been hiding in the command line interface, or the CLI. I just love this quote because it's that moment of discovery. The CLI, the black screen with text, can feel a little scary at first. But as the student found out, it unlocks a level of precision and power that the web console just can't touch. There's a reason so many data pros live and breathe in the terminal. So let's check out an example. Instead of trying to do a broad query that fails, what if we just want to grab one very specific item that we know exists? For that, we can use a command called getItem. Now, just look at how clean and precise this is. The student is using that getItem command to pull one single item from their content catalog table just by giving it the full key. And look at the output. It's perfectly structured JSON. This is the power of the CLI right here, going from clumsy, failing queries to these super specific, highly efficient lookups. Let's break down what's happening there. That @key flag, that's your laser pointer. It tells DynamoDB exactly which item to grab. Then there's dash projection expression. That's your efficiency tool. It stops you from getting back way more data than you need. You just specify the exact fields you want. And dash return consumed capacity, that's your cost monitoring tool. It tells you exactly how much that query cost you in read units. Okay, so we've gone from simple queries in the console to very specific lookups in the CLI. Now, let's look at one of the most powerful features you can access from the command line, transactions. And trust me, this is where things get really cool. So, what even is a transaction? Well, imagine you need to do two things that are connected. Like you need to add a new comment to one table, and you need to update the total comment count in another table. A transaction bundles those two actions together. And the critical part is it's all or nothing. Either both actions succeed perfectly, or they both fail completely. You're never left with your data in some weird, inconsistent state. Okay, whoa. I know, this looks like a lot of text on the screen. It's the transact-write-items command. But don't get intimidated. If you look close, you can see there are two main chunks inside. There's a put action for the comment table, and there's an update action for the forum table. The magic is that the CLI is bundling these into one single safe operation. Let me show you what that means in plain English. See? When you boil it down, that's all that command did. Two simple steps in one atomic command. First, it used a put operation to add a new comment that says excited to attend into the comment table. At the exact same time, it used an update operation to add 1 to the comment counter in the forum table, all in one safe, single transaction. So, what did we learn following this student's journey? Well, the console is an awesome place to start. It's great for basic exploration. But the CLI is where you unlock the real power, the precision, the advanced features like transactions that are absolutely critical for keeping your data correct. And probably the biggest lesson of all, don't be afraid of the command line. It's your friend. And that brings us to the end. I want to leave you with this question to chew on. Think about your own projects. Think about any time you transfer money, or process an online order, or book a flight. Those are all multi-step things that have to succeed or fail as one unit, right? So what's a complex process in your work that could be made way safer and a whole lot simpler with a transaction? Something to think about.